Howdy, I'm James, and today we'll be going over inheritance and polymorphism. Just to preface this, you should already understand the concept of object-oriented programming. You can think of inheritance and polymorphism as two different yet intertwined ideas. Inheritance is how an object can be derived from another, like a parent-child relationship where both the parent and child share certain features, like eye color, hair color, and height. Additionally, the child may differ from the parent in weight, sight, and gender. Polymorphism, meaning many forms, is how those inherited classes use methods and functions from their parent class. Continuing our parent-child analogy, polymorphism is similar to how a parent and child might differ in the way they do things. For example, the parent might throw a ball underhand, whereas the child may throw overhand. They both effectively achieve the same or similar goals, but they do it in different ways. Here we have a standard class-object relationship. If you recall from object-oriented programming, classes create objects, and those objects can have methods and variables attached to them like so. However, what if we want multiple objects that share some similarities with each other, but have functions and variables not found in both? Simply rewriting the class to handle all of them would be tedious and frankly take up more time than needed. This is where inheritance comes in. In this example, instead of there being one vehicle class for just a car, there is instead a vehicle class with derived classes, the car class and plane class. Each of these classes has their own objects that share some things from the vehicle class and their respective classes. Now, even though any given subclass might have some of the methods within the parent class, that doesn't necessarily mean those methods will act the same. Looking at the function inspection check, you will notice how it has no parameters attached to it in the vehicle and car class, but does in the plane class. This is one of the major benefits of inheritance and polymorphism, the ability to change functions as needed. This is the code for the vehicle class. You'll notice it is pretty standard to object-oriented programming, and there's really nothing too special about it. However, if we look at the plane class, you'll notice that it completely lacks any of the variables found in the vehicle class. So why is the constructor taking in all those variables? That is because it has inherited them from the vehicle class and does not need to explicitly declare them. This is great for code reusability and one of the major benefits to inheritance. You'll notice that the class declaration for the class plane has a colon and then the name of the vehicle class. This is simply the C++ syntax for inheriting classes. Looking at the car class, you will see much of the same. However, the car class has a ton of variables that the plane class doesn't, and lacks the variables in the plane class. Additionally, it has its own function that neither the vehicle nor plane class has, use muffler. All the variables and functions declared in the car class can only be used by a car object. Similarly, all the variables and functions declared in the plane class can only be used by plane objects. But what if we have an object that we want to use both the plane and car class variables and functions? This brings us to multiple inheritance. Here we have the flying car class, wherein the car inherits from both the car and the plane class. This allows the flying car to utilize all the aforementioned variables and functions from both the plane and car classes respectively. This can be extremely useful for not having to rewrite code. However, you might have not noticed it, but there is an issue with this code. Pause for a moment and see if you can get it. Got it? Don't be upset if you didn't. This one is quite tricky to see. This class has two different inspection check functions assigned to it, one from the car class and one from the plane class. This can cause an error where the compiler doesn't know which one of the functions to use, even though it is the exact same one from the vehicle class. This is known as the diamond problem. You can see here that the plane and car classes inherit from the vehicle class, and the flying car class inherits from the plane and car classes. Since both the plane and car classes have an inspection check function, so too does the flying car class. So how do we fix it? Introducing the virtual keyword. The virtual keyword effectively abstracts the function, variable, or class you attach to it. I find it easiest to think of it as creating a pointer to a location in memory that stores that particular function. This solves the diamond problem by making it to where, instead of providing duplicate functions, instead provides the same function by pointing to the exact same place in memory. One more thing to note before ending this video: there is an access specifier unique to inheritance called protected. Unlike public, where anyone can access the variable, function, or class directly, or private, where nothing else can grab the variables except the class in scope, protected makes it to where only classes that have an inherited relationship with the class containing the protected values can access them. So, if a parent class has a variable like name, a child class can also access that variable, but nothing outside of that relationship can access name.